myself Maruti, welcome you all to this physics video session now. Right, so in this video, I'm continuing the topic what I have said earlier. That's nothing but the structure of the atom. Earlier in my last videos, I have said to you regarding what is the assumption of Mr. Bose and what are the assumption of Mr. Sommerfeld regarding the structure of the atom. Now in this video, I'm going to tell regarding quantum mechanical model of an atom, right? So before getting back or getting into the concept, let me deal what Mr. Bose has said and what Mr. Sommerfeld has said regarding the structure of the atom and how the electrons are revolving around the nucleus. That's the concept. This is here. Quantum mechanic model, that is what are the assumptions of Bose and Sommerfeld? Right, electrons revolve around the nucleus in a fixed path or definite path called as orbit or shell according to Mr. Bose and also Mr. Sommerfeld. Right, they are having fixed path. They had given a fixed path. Of course, I am talking about fixed path. I said both Bose and also Sommerfeld. What was Mr. Bose was saying according to about the position or the in which path it is moving? Let's deal what is Mr. Bose saying. Right, Bose, according to Mr. Bose, if nucleus is here, electrons are revolving around the nucleus in a specified path. Let's take the path of the electron like that. Yes, right. And what is Mr. Bose saying? Bose is saying that electrons are revolving in a specified path. This is the path what we have said. Electrons are revolving around this one, and these are called as orbits according to Mr. Niels Bohr. That is what Mr. said. Again, according to Mr. Sommerfeld, what was Sommerfeld saying regarding Sommerfeld? Right, what is Sommerfeld saying? So here I took the example of n is equal to 1, that is K shell. I am taking the example of K shell. Whereas if you deal with the Sommerfeld wantedly, I am taking second orbit KL it is, right? I am not talking about the first orbit, I am talking about the second orbit. What is here, if it is the nucleus, and what is Mr. Niels Sommerfeld is saying means, assume that this is the second orbit. Yes, and for that second orbit, he is talking about an elliptical model. Elliptical orbit means as n is equal to 2, he is talking about two shapes. First orbit is nothing but spherical. Right, first orbit is nothing but the spherical, and the second orbit is nothing but elliptical. Right, so this is elliptical and this is the circular one. So what Mr. Bose is saying means electrons are revolving around the nucleus in a fixed path called orbit. Right, of course circular orbit is talking about. So here it is nothing but circular orbits. Right, this is Mr. Bose model. Whereas Sommerfeld is saying yes, they are moving in a circular orbit. The first one is the circular and the remaining all, as many they have, they all are elliptical orbit. This is the assumption of Mr. Niels Bohr, circular and elliptical. These are the assumptions. That's what electrons revolve around the nucleus in a fixed path called orbit or shell. Now my question is, right, are they correct? Are they correct? Are the assumptions perfect? No. This is opposed by, right, Mr. Erwin Schrödinger. He opposed it, saying that no man, I don't think. Why? Because if they are moving, of course, you have to remember one more point here. Though Mr. Bohr said this and Sommerfeld for this, they were not able to give a satisfactory picture of the structure of the atom. You have to remember, that's what. They did not give a satisfactory picture of the structure of the atom. Both Sommerfeld and also Mr. Niels Bohr, they didn't give a satisfactory picture of the structure of the atom. Right? Yes, because of that also, Mr. Erwin Schrödinger has opposed their model and they said, no, what you are making an assumption that the electrons are revolving in a circular path is wrong. I am opposing your model. So he came out with a new model. Who is that? Mr. Erwin Schrödinger. Right. He came out with a new model called as quantum mechanic model of atom. This is the new model what Mr. Erwin Schrödinger has brought, opposing what Mr. Bose and Sommerfeld has said. You got what Bose said and what Sommerfeld has said. Now, why he came for that assumption? Why he opposed? Why? Because if electrons are revolving in a circular path, fixed path, we should be able to know exact position of the electron, which is not at all possible. This is the point which made Erwin Schrödinger to oppose Sommerfeld and Bose and come out with a new model. I repeat, right? If electrons revolve around the nucleus in a definite path, exact position of the electron at various time can be known. If this is the point what you have to stress on. If they are moving here only, we can find out the exact position. Imagine a person is moving here and there, and if he is moving in the same position, if you take a pic of that, we can know exact position of that, right? And next time also at the same time, we can see it will be there only. But what we are not able to figure it out the exact position. That's what. If electrons revolve around the nucleus in a different path, exact position of the electron can be known. But many experiments which were made after the discovery or after the assumption of Mr. Greer, right? Many experiments came out. They all are saying that exact position of the electron accurately cannot be found there. That's what. But experiments prove that position of the electron cannot be measured accurately, because as we are not able to figure out the position of the electron accurately at a particular time, Mr. Erwin Schrödinger has opposed, right, and he came out with a new model called, right, the quantum mechanical model. Of course, to support this, we'll come out with an experiment what Mr. Erwin Schrödinger has been conducted to know the position and velocity of the electron accurately. I'm going to explain you now. Now, let's consider a light of very small wavelength, right? Let me consider, I'm talking about light, right? So this is nothing but the light ray, let us call it as. Now, as we all know, the distance from here to here is nothing but the wavelength. Okay, so light of short wavelength, very short. Why did we take very short wavelength? Why? Because atom is there, right, of course, in which we are having nucleus, and the electron which is present or which is around the nucleus, whose position we are supposed to find. It is a very small particle. It's a very small particle, right? As you all know that, right? As it is a very small particle, we have chosen a light of very small wavelength. Okay, now what is the experiment? We have chosen a light of very small wavelength, and we are talking about an atom. Now, with the help of any source of light, let us take any source, right? Source of light, let us take any source of light, and let us focus the light on an atom. Assume that these are the light rays. Okay, of course, I said the wavelength of the light rays is very small, right? Now, let the light rays are falling on an atom, right? So, of course, we have nucleus at the center and the electron. Okay, now focus here. You have to remember one thing, right? That is, the electron is in motion, right? So, electron has both position, right, and velocity. Why it is having velocity? Is the electron moving? Yes. Now, are the light rays which are coming or which are focused, do they have velocity? Yes. Why they are having velocity? Means they are in motion, right? So the light ray is also having velocity and the electron is also having velocity. That is moving and this is moving, right? Actually, why the experiment is done? To know the position of the electron. Let us conduct this experiment. Now, when the light rays are coming and when they are focusing, this is under motion and this is under motion. When they both interact with each other, they disturb the light ray which is coming. When it interacts with the electron, obviously it disturbs the position of the electron. That is what he says. Light rays of very short wavelength is made to focus on the atom to find the position of small particle called electron. This moving light interacts. When it is interact with the moving electron, it disturbs its motion. Both the position and also the velocity of the electron changes. Alright, means just I like to say only one thing. The only option what we have to find the position is nothing but a light ray of very small wavelength. Right. If we use that also, we are not able to figure it out. Right. So here what we will say, what to say here means as it is not moving in an exact position, right? If we were able to find out the position, means it is moving in the same orbit. Right, we are not able to find it out. We are not able to find it out. Why? Why? Because it is not in an exact position. If it is in a fixed position, we might have found it. Right. As we are not able to find it out, what we can say that yes, there is no accurate position of an atom around the nucleus. That is what we are saying. Right. Simultaneously, both position and velocity of the electron cannot be measured accurately, right? If we were able to measure, then we might have said that it is moving in a specified path in a fixed position. But as we are not able to find it out, why we are not able to find it means it is not moving in a fixed path. That's why we are not able to find it out. Though with the help of the only experiment what we can do. This is the experiment which is supporting that Mr. Erwin Schrödinger assumption is correct and Mr. Bose and Sommerfeld assumption that it is moving in a fixed path is wrong. Now, what are the assumptions made by Mr. Erwin Schrödinger in his quantum? Basing on the experiment conducted with the help of a light with very small wavelength, Mr. Schrödinger has come out with a theory, magnetic quantum number theory, right? According to him, what are the assumptions made by him, right? Before getting into that one, let me tell you a small point, right? So, what is the meaning of position or what is the meaning of region? Okay. Now, if you have a single point labeling with something A or B, we call it as a position at particular time, right? If you specify position means exactly one point, exactly fixed space, right? Instead of that, if you take any three-dimensional picture, right, any three-dimensional picture, the space inside is called region. The space inside is called region. Right, we should know the difference between position and the region. Okay, now what Mr. Erwin Schrödinger has said based on the experiment means electron is not present at particular position at a particular time. That is what he says. This is wrong. This is what Mr. Erwin Schrödinger says. He says, right, there is no exact position of any electron at a particular time, but there is a chance of existing of the electron in a particular space, right? Mr. Schrödinger, he didn't give a particular place of an electron at particular time. But what he's saying, it is not, we can't tell exact position of the electron at particular time, but we can say that it may be present in that space. Exact position we can't tell, but there are much chances of the electron present in that space. The electron might be somewhere in that space. Exactly we don't know. Exactly we don't know. Exact position is not possible, but we can tell that there are much chances of the electron to be in that particular space. I am talking about the space inside the box. Inside the box, it may be at any place. There are much chances, means maximum probability, means maximum chance of existing of the electron in that space at that particular time. Hope you got the difference between a particular position and chance of being that electron in that space, right? Maximum chance of the electron at that particular time in that chance. Okay, that is nothing but orbital, right? Orbital. That's what he says. Electron exists in a particular region. He is not saying particular point, particular position. He is talking about the region of space around the nucleus at a particular time. If you take the electron nucleus here, right, we are taking the space, the general space. It might be somewhere here. This space, he is calling it as orbital. Right, that is what the point is. The region of space around the nucleus where there is finite probability of finding the electron around the nucleus. There are much chances of the electron to be present at that place at particular time. That space is called as an orbital. That's what. The region of space around the nucleus where the probability of finding the electron is maximum is called as orbital. This means Mr. Ehring-Schrödinger has brought a new concept called orbital. Right, he came up with a new concept. So now, regarding to about that orbital, he has given certain numbers called quantum numbers. Right, the quantum numbers are n, which is nothing but principal quantum number, L, which is nothing but azimuthal or angular momentum quantum number, or ml, magnetic quantum number, and ms, spin quantum number. These are the set of quantum numbers proposed by Mr. Ehring-Schrödinger. Quantum numbers, all these four are telling about a particular electron. To know about the position of the electron, size of the orbit, energy of the orbit, and lot of information can be given if you know all these four quantum numbers. That's what he says. Information about orbital given by the quantum number are size and energy of the orbit is given by the quantum numbers, and shape and number of orbitals present. This is one of the space. That region is nothing but orbital. How many number of orbitals are there, right? But you have to remember that every electron present in the orbital has a set of quantum numbers. By knowing the quantum numbers, we can tell the size of the orbit, energy, and the remaining all stuff. So this is the great thing what Mr. Ehring-Schrödinger has done by bringing the new concept called orbital, which brought a great revolution in the history of science. In this channel, I have been placing both math and science videos.